Hey everyone, in today's video, fresh out of the dumpster, we've got a Tandberg 3026A. That's what the guy who owns this told me. He got this right out of the dumpster, paid nothing for it, and he wants me to get it working again for him. So let's take a closer look, see if we can get this thing back to what it once was. Yes, Sadie is enjoying the cool summer breeze. Well, okay, it's springtime, but it feels like summer. At least it did yesterday. Anyways, the Tandberg 3026A, 150 watts per channel into 8 ohms, and it's from the mid-1980s. I've never worked on anything Tandberg before, so we'll see how this goes. But overall, pretty nice looking amp, looks powerful, looks nicely built. And if we peek back here, looks like we can see some TO3 transistors back there. Very standard, that's what just about most things have. The whole chassis is basically its heatsink. Kind of reminds me of my Marantz 240 power amplifier. But if we take a look back here, pretty simple. Not much going on, just some speaker outputs, power cord. You can set it to whatever voltage for whatever country you're in. Oh, she's never jumped on the roof before, but I should probably intervene. Hey, you want to not be here? Yes, model shot. Gorgeous kitty. Scratches? Yes. Good scratches. I know my viewers love the cats, so here you go. And then with this amp we had some parts included. We had a new power switch, so looks like this might be the old one. I think I see why this is here. I don't think I'd want to turn on my amp with that. I'd much rather use this. So we will definitely use that. Then the power cord, very nice. So how about we get this thing on the bench, see what it's all about, and see if we can get it working again. Well, obviously the first thing we've got to do is figure out how we're going to get this new power switch in. I see 2 hex keys in the back here, and they are loose actually, so I'll just go ahead and remove those. There are also some hex keys in the front here, and since this is from the Netherlands, they are probably metric. I said hex key earlier, I meant to say hex bolt, because I'm holding the key. Oh, that's interesting. 2 different length screws already. Let's see if these are also 2 different lengths. Okay, that's fun. The long ones go on the outside. Let's see if I can remember that. Is this loose now? Yes. Well, there are 2 Phillips back here, so maybe we should look at those first. And there's 2 even smaller set screws back here. Okay, that helps. And then this comes up like so. Aha, and then this has 2 Phillips head screws in it. Okay, now it's apart. So we'll just want to put this like that. And now, it would appear we just want to snap this into place. How hard do I have to press these guys? Okay. There's the power switch. Then we've got 2 spade terminals. I'm assuming they go on either one of these, but let's just be absolutely sure and check with a multimeter. Okay, so we are turned off. We should have no conductivity between these 2. Now we turn it on, and we should have conductivity. Yes, we do. Okay. That's how that works. Let's plug these wires in. There we are. Alright, let's get our faceplate screws back in so we don't have anything to worry about there. I'd say it's highly doubtful that I need to take the faceplate off again, so I'll just go ahead and tighten all of these. So there's a little bit of a closer look for you. Pretty straightforward in here, power amplifiers generally are. But I want to do something real quick to start before I even power it up. So we know that we were told this is not working. Then when power amps fail, it's generally, at least I think generally, an output transistor or a power supply or whatever. So first, let's go ahead and check this fuse. You need a flathead to check this fuse. Our fuse is good. It is an 8 amp 250 volt fuse. Next thing I want to do is check our output transistors. So you can tell this thing was hand assembled to some extent because there are not nice little connectors here. They just soldered right onto these things, unless I'm not interpreting that correctly. But anyways, you can see the output transistor pins kind of sticking out there. So if there's a problem, we'll know because we can... Okay, so that would be a problem, right? We have a shorted transistor already. Unless this is wired in some way. Nope, false alarm, folks. That's not a shorted transistor. I'll show you what it does sometimes. Sometimes when you put it on continuity, you'll get this kind of activity, so I'll put it back. See, it's beeping, but our resistance keeps going up. And then it eventually just keeps going up and there is no short. So these would be okay. We just have some goofy charge existing inside of here somehow that is causing that to happen. See, there it is, but less severe. And then we'll wait a long time for this one to go away. But yeah, you can see it's gonna be alright. Probably not a short there. Okay, let's try the other channel. Do we get the same thing? Okay, outputs are okay. So I think we're ready to throw this on the dip bulb. Let's get that into view for you. Let's use the 90 watt bulb. I've got the 200 in there right now. The 90 is going to be a little bit nicer for us. I've also got the kilowatt where we can monitor the current draw. Can you read that? Yeah, not too bad. So let's plug our amp in. I'll turn the dim bulb on, the amp is off. And now I'll turn the amp on. Let's see what happens. Okay, it's a little bright. So while we've got that, let's check the rail voltages on our filter capacitors and see what's going on there. See if they're equal and opposite. So put voltmeter on DC. We will attach to ground, which looks like this would be a nice spot for that. And let's see what we've got here. We've got a negative 21 and a positive 21. So that's a good thing that they are equal. The relay is definitely not clicked in yet, and I don't think it will under these circumstances. Let's try the bigger light bulb and see what that does for us. What does that do for us? We draw 0.8 amps instead of 0.5 amps. How much more volts do we have now? We got 44 and 43. And that time we got a relay click. And these voltages are slowly going down. Supposedly as we draw more current, I guess. But these voltages are equal, which means our caps are probably okay and our bridge rectifier is okay. So this thing is getting the power it needs, and we just had a relay click. Let's see what's happening in our speaker terminals. Do we have DC offset there? Small one at the left channel, and then at the right channel, nothing. Nothing at all. Okay, there's something. Okay, I always get suspicious when I see nothing at all at a speaker terminal, because like, there's got to be something, you know? But here, it would appear we've got a working amplifier, I guess. But obviously if it came out of the dumpster, there is something wrong. And we still must figure that out. Alright, so the thing's been powered on for a little bit. I printed a service manual in that time. There's really not that much out there for this thing, but this is a 4-page PDF with the 4th page being this one. Yeah, they really don't give you much. But yeah, these 3 pages can be arts and crafted into a 1-page thing. Then here's all your adjustments, and then some info on if you're going to change Q103 and 104, which are FETs in the early amplifier stage right here and here. But hopefully we don't have to do that. First thing we're going to check is what they're calling the, how do they call it? I've never seen this word. Q-U-I-S-C-E-N-T? Quiescent current or something? I don't know. Idle current is what I interpret that to be. It says it should be 30 millivolts across R505 and 605. Well, guess what? R605, to the best of my knowledge, does not exist in this amplifier. But we have 305 and 405, and they are in the vicinity of the output transistors. So I would imagine if you measure across these big resistors right here, which are, like I said, R305 and 405, that might get you your idle current. So it says it is supposed to be at 30 millivolts, and the adjustments are labeled on the circuit boards. So it took me a minute to get some clips clipped to the bottom of these things. You might be able to see that. It's just, it was quite painful getting something underneath there, but eventually I got it, and that's a good thing. So now we can just take our one probe and put it there and see what we get. So for the right channel, if we put it right here, we should get a number, and that's 25 millivolts, so that's good. Now, if we switch our negative probe to the other side, let's check on this one. What do we have? 25. Now, if I am correct about that being your idle current adjustment, we should be able to take this here massive screwdriver, probably not the ideal tool, but it's a plastic trim pot. If I put this here and we turn this screw, yeah, that's definitely it. So there I'm able to adjust it. So we'll leave it at 25 like we found it. There's nothing wrong with the idle current on this amplifier. What else do we have to check here? The next place to check are 150 and 250. It says the voltage across R150/250 should be 2.65 volts plus minus 0.65 volts. That's the best I can read that. So all measurements must be made with a probe having minimum 5k ohms resistors in both terminals. What does that mean? I'm just gonna measure it and see what happens. First I need to find it. Where is R150? There, I found it. You can see R150 there. It looks cracked almost, and the paint's missing on part of it. So I don't know. I'll put my probes across it. I'll see what number I get. I have 2.57 volts. Then our 250 is over here on the other side of the amplifier for the right channel. Let's see what we get over here. My multimeter says 2.06 volts. So that's wrong. This is mentioned in a step that is talking about the distortion unloaded control. That's R231. So R231, is it that one there? That's 233. 231 is over there, that one there. So I wonder if I adjust that pot while reading across this guy. Does that change anything? It does. So I'll just bring that up to 2.5, something like the other one. Alright, you couldn't see that, but changing it brought it up to 2.57 on there. There, I'll prove it real quick. Holy God. Alright. Whatever. Now let's just check that again. Of course, I broke it. Now we have negative 1.9 volts. Well, it had almost appeared that we were going to have a working, normally functioning amplifier that had no problems, but yeah, I just completely roasted the right channel there. So now we got to figure out what it is that I roasted, and go from there, see if we can recover from this. Okay, I've done some poking around, and I think I've tracked it down to the negative supply rail for the right channel. So here's the right channel. You can see we were supposed to have a negative rail down here and a positive rail up here of about 74 volts. But coming into that, we've got some slightly different numbers up here. I don't really know what that's all about. It says, I think it says 65 and 66 up there. But like, yeah, the dark blue wire is supposed to give you your negative stuff. And I have that. And if I measure up to the collector of Q227 here, you can see, it's basically a direct connection. We should have that voltage, and we do. But then we go through this mysterious box here called reg negative, and then you check it over here at Q223, and it's like 10 volts, negative 10 volts that is. So I found that when I was probing around. I looked at this resistor right here. It's a pretty big one in the cabinet. There's that one there and that one there. I don't know what reg is, but we're gonna have to find out. And I'm thinking in order to do that, we're going to need to take out that board, because this is a dual layer board. We've got a layer on top. It looks like kind of a ground plane layer up top. And then all of our traces for all the circuitry is going to be on the bottom. And I can't see anything. I don't know where these traces are going. So I'm going to see underneath what is reg. Another interesting thing I've noticed is someone's been here before, because these screws are very rounded off. Like, that's gross. I hope I'll be able to get that out. And then there's also some components that are present on one side and not on the other side. It could have been from the factory, but where was it? Yeah, like right here. You can see somebody literally clipped something out of here. It's really bizarre. So, I don't know. Let's take a look underneath. And lucky for me, I think it's just going to be undoing these connectors, and then we should be okay. I'll take this resistor and discharge my filters. And all right. Okay, I am figuring some things out. I have determined that it is a power supply issue, or at least I think I have at this point. The way these schematics are written are really misleading and really obnoxious. So this is your actual power supply right here. Like, I guess your rail voltages come in off of your filter capacitors, but then it also does a bunch of stuff to make a positive 72 and a negative 72. And I think our negative 72 on the right channel is not working. But also, like I was showing you earlier, like I got to figure out what reg minus is. And I think this is just saying you have your negative 88 right here and then your negative 72, or it says 74. That's another thing that's really confusing. It says 72 on here, but it says 74 over here. So it's like, okay, which one is it? And then why is this drawn this way? Why is this drawn as if it's a component that has two leads on it? So like, I take out the circuit board, I'm following all the traces, and this just goes to a diode that goes to nothing. There's literally a diode that's not on the schematic that's mounted on the board, and it just goes to nothing. It's just sitting there. And that's really weird to me. And it took me a long time to figure out what the heck was happening. So, and then also, there's nothing on this showing the fact that your negative 72 or 74 comes off of this thing, and it's these three wires right here. Your positive 70 whatever is this red one, your negative is this blue one. But why didn't they put a connector on the top of this thing? There's a connector on this board, and that's kind of what I figured out. I was able to disconnect it. But and then one more thing, I was looking for, R52, C52, but then I saw this note right here. You got to add 500 and 600 to find these components, and they're all crammed into this thing right here. I only have a foil view of this board, which, you know, it's not too valuable because of how crammed it is. So that's been a real trip. Not gonna lie. So anyways, I'll show you why I think it's power supply related. So this board is basically completely out of circuit right now. So what I can do is I can power this thing on, and I can show you with the multimeter in view. I know that the back of this resistor has our 72 volt rail or whatever. So if I measure the back of this resistor, I get that negative 73 volts. Great. That's what we want to see. If you recall, on the other side, we got something like in the 10 volt range. So let me turn that off, and I'll discharge the filters again for safety. And again, these circuits are identical. We see they're identical to the point where they got so lazy they left this out of the main schematic and just said, oh, add 500 or 600. So let me take this out of there, the 600 part, and we'll plug it into the 500 part because that's what this is over here. Okay, we've done that. We'll turn this back on. And now, let's take a look at that resistor again. And we see, yeah, negative 12 volts. So that is way less than the negative 72 we're supposed to have. Obviously, that wouldn't just happen if it weren't something originating from here, because you could argue that, oh, well, this is pulling really hard and it's dragging down that voltage a whole bunch. Well, if that channel is healthy on one side of the power supply and unhealthy on the other side, well, then it's probably your power supply. So this board is really tough to look at here. I think I'm going to have to remove it and test components from underneath, because I can't get my leads jammed in there enough to see what transistors may or may not be shorted or whatever. Oh, wait a minute. I have not looked at the bottom of this receiver. Oh, wait a minute. I might be in luck. There might be a service cover underneath. And there is. Look at that. Okay, I like these guys a little more. Oh, but somebody tried servicing before me. Hopefully they... Yes. Oh my goodness. Look at that screw. That is rounded off. That is not nice. Luckily they weren't able to tighten it. Jeez. Maybe I should start looking at the bottoms of these things more regularly. It's like, if I had done that, I wouldn't have had to pull that board out. Silly me. Alright. I like that a lot. That makes life so good. Alright, it would appear we have found a problem. I was going through probing stuff under here, and then I found that noise. And it was when I went across these two pins of this guy right here. This is Q553, and you know, sometimes when you get weird readings on the multimeter in circuit, they don't always turn out to be true, but generally, if you get a short circuit, see short circuit on green blue, it's generally, yeah, actually a short circuit. So this one's got a weird pinout. The pinout did not match what was in the service manual. Like in service manuals, they always give you like this section right here where it's all the transistors and their pinouts. And what I was reading did not line up with what this was. So I pulled the other one, got its pinout, and then looked up the data sheet. Found that MJE15033G matches kind of closely. Not perfectly. The transition frequency is about double on this one. It's like 70 megahertz versus 30 on the 33G, and the pinout's completely different. So I had to do the thing where you take the heat shrink, put a piece over, and then bend the leads a little bit. So I'm ready to solder those back in right now. After I do that, I'll keep looking around to see if there's any other shorted transistors, but I think that that's gonna be okay. All right, a little more stuff got checked. I'm willing to turn this back on and see if our voltage problem is fixed. So we'll go back on here. Do we power up? That's very good. Now, if we recall, there was not 72 volts at this pin. And now there is. Great. I like that. So what I'm going to do is I'm going to put that right channel PCB back in, and maybe our relay will click once again because it stopped clicking in once we had this problem. Alright folks, it's the moment of truth. Let's see if everything is okay. Relay click? Yes. Let's not make that mistake again. We are very lucky it was just that little transistor back there. Let's go ahead and double check that our voltages are equal on each side for the 72. So blue wire right here. Of course, it's a smaller number now because we've got both channels pulling current. It's negative 59.5 and negative 59.5, so we're equal, we're the same. The MJE 15033G was a good sub in this particular situation. We are lucky. Anyways, let's check our speaker outputs again. I was about ready to hook up speakers and see what's going on with this thing. Okay. So on our right channel, maybe we're not completely done. We've got a large amount of offset on the on that side. So that could have something to do with the fact that I played with that distortion adjustment. Again, let's check to see what that resistor is and not do the same thing we did last time, because this is the one we measured. Are you f***ing kidding me? How the f*** did that even happen? I just touch it and it does that. That's so weird. I'm not... Oh. Maybe I'm shorting it to the ground plane. On this... Oh, that's such a stupid design. Yeah, that's what I did. I just shorted it to ground because the top of the PCB is ground. And I was jamming my pin in too far. And then that's what happened. Okay, well I didn't break it this time, apparently. We've got our negative 60. And our negative 60. Okay, do we still have our bad offset? Yeah, that's even worse now. So, let's see. Does that change at all when I turn this one? Yeah, it does. Okay, so I can bring that right back in. No problem. The other side likes to jump around plenty as well, so. Okay. I'm ready to hook up speakers now. Alright, just to make that absolutely clear what happened. So let's move this guy out of the way. There it is, R250. That's the one that I had the Sparky Sparks with, and you can see on that left side leg, it's well, you can see where the burn mark where I shorted the probe to ground, because that's what's going on here is this whole bright green area. I can catch the edge of that copper with my probe, and then I'm against that resistor lead, but the very tip of my probe is kind of getting itself under that ground. So that's what was happening, and that makes sense. You know, I was looking off camera earlier at, like, you know, how the heck did that happen? I don't know how that happened. Enough talking. I'm going to hook up some speakers and see what we hear out of this thing. Okay, without further ado, let us cue up everyone's favorite song. Okay, it is working on the right channel, but the left channel we have nothing. It's because we have a bad relay. I get popping when I do that. And this clicks in and out when I do that. So that means maybe the relay is not pulling strong enough and we need to come off the leash. If I had a higher watt bulb, I would do that, but let's come off the leash instead. Let's just go for it. Okay, we'll do. Turn it on. That dims the lights. I'm pulling an amp, and there's smoke. What is smoking? What is smoking? Alright, so I've disconnected the speakers just because I don't trust this thing, obviously. So let's check some voltages. We still have our negative 66 and our positive 66, so that is okay. Over here we have negative 90 coming in and positive 90 maybe. Negative 90, positive 90. Coming out of the power supply we have negative 90 and 74. The right channel is getting too much. In the left channel we've got our negative 74 and positive 74. This is not my day. This is not my day. You can see that right there. The case of that transistor literally exploded. So I should have been wearing safety glasses. And then in the general vicinity, that happened also. Yeah, so I guess I'll replace those. Alright, we are flipped over, and the relay is going to be right there, those pads in that area. Let's get the Heiko FR300 on there and start getting some solder taken away. What I like to do is just kind of heat up these tabs and see if I can get them to move around or kind of break them from that little tiny bit of solder that might still be holding on. And yeah, I can heat this up and kind of bend it to the side, and then that's going to keep it from sticking to the pad and give us a better chance of successful extraction. In fact, there we go. So it looks like all of them are free. There she be. And there you go. And of course we can see the pinout between the old and the new is the same. And looking inside, we are basically exactly the same there. So this new one will operate exactly the same. Let's get this new one in. Now, of course, you want to make sure that's sitting in there nice and snug. You might want to bend a tab or two. Get a little bit of a mechanical stay power in there, per se. But this fits pretty snug as it is. I don't need to bend these tabs. So I'll just go ahead and carefully get this first one here. I need to wait a little bit longer for that to heat up. Got the tip at 700 right now, maybe 800 would be better, but I've had some issues with breaking the traces on the other boards, so I want to be careful, but since these traces are so big, that might not be too bad going 800, but I appear to be having pretty good success here, so I'll keep it at the 700. 700 degrees Fahrenheit, that is. Don't worry, my international viewers, I am just as angry about the Fahrenheit system as you are. Now I think this one I'll need to turn it up. And for this one, I'm going to clean it up a little bit. We don't need solder where I just pulled it from. And now I've got the tip at 800, so I can get better heat on this joint. There, that's behaving much more nicely for us. And we'll just kind of go over here again. It's looking okay, but I think this is where the speaker output wire goes, so certainly no harm in getting more solder right there. I'm seeing in the camera where I didn't do so well, so we'll have to go redo that joint that's closest to you all right here. Make sure that's nice and filled in all the way. There we go. Gotta make it look good. Alright, plenty of stuff has gone down in the last week or so. So the area we're going to be talking about is located right in here. This is our regulated power supplies for the right and left channels. They're supposed to give a plus minus 72 volts to the power amplifier. And it's very misleading, like I talked about earlier. I hate the way this is written. There should not be this block right here. There should just be nothing here. There should be a line coming out of here that says 74, like this. It says 74 right there, or negative 74. This shouldn't be here. Like, just delete this. So just to be absolutely clear what happened earlier, let's look at this rail right here. You know, this is coming directly off of our regulated power supply, which is on the other page. And that is right here. This is our negative 72. It says negative 72. It should say negative 74. And that should say positive 74 based on what I've seen so far. So what happened is we were trying to measure that resistor that we're supposed to measure across, and what happened is we shorted this directly to ground. So what did that do? Well, it pulled this negative 88 volts straight through here, and yeah, destroyed this and that and that. And I don't think it destroyed that one, but it destroyed all these. And then through my own stupidity, it destroyed all these three also. And then one of these caps on here, I think it might have been this one, was actually spewing smoke at a certain point. It was very bad. And it also destroyed these guys right here. What are these guys? These are Zener diodes. And they're kind of important for the function of this power supply. So it is no coincidence that 36 plus 36 equals 72. So that's kind of what's going on here, is you've got these guys going to ground, but they're kind of regulating the voltage in a way. So what's happening at the anode of these guys is we've got the negative 72, and the cathode of these guys is the positive 72. All four of these got taken out. So essentially we had nothing, and I think there might have been some point in the video where I checked right here and we saw 90 volts which is the same as this. So that basically meant we had a short circuit right through here, and that's not good. So I replaced all these transistors. I've got a graphic that I'll put up on the screen right now. I will show you everything I replaced the stuff with, and I replaced all the electrolytic capacitors. The transistor subs seemed to be fine to me. Like, I checked data sheets, I checked values, and came to the conclusion that the ones that I've got in there are suitable replacements. But there's something very wrong on here, and I didn't learn this until later. The ZY36 replacement Zener diodes, it does not say on this schematic the wattage value or power value for the Zener diodes that are in here. So I had the bright idea of, okay, while I've got those out, let's just bump up the power value. So I put 2-watt Zener diodes in there. And what happened was, we, instead of having plus minus 72 at those Zeners, we had like plus 77 and minus 79. So like a bit higher than it should have been, and unequal. So I phoned a friend, and they said that when you go to the higher water Zener diodes, they are less precise per se for the applications. So it's likely that they were half-watt Zener diodes. So I bought some half-watt Zener diodes, put them back in the right channel power supply, and that fixed things. So let's take a look here. Now what we've got going on the right channel out of the regulated power supply is -75 and 75. So like a little bit uneven, but much better than it was. Then over on the left with all original parts, we have -74.6 and like 74.3. So we're like a volt higher on the right channel with our new Zener diodes. So what I'm thinking is maybe it would be a good idea to replace the Zeners on the left channel so we get equal voltages on each channel. So I think I will give that a shot and see what I get. Alright, that's taken care of, and you can kind of see over here my mishaps. The 2-watt Zeners, the wires were very thick and it destroyed the traces. So luckily I've still got the one trace in place, but the one to the left there, that is just the two of them together. So if you just solder the tips together, that's fine. Then over here you can kind of just take that lead and extend it to the next working joint. It's not exactly the correct way to do it, but it works. Now that we've done that, let's put this thing back down here, and let's see if our voltages are equal now, which is what we want, because you want your right and left channels having the same thing. So I don't think I messed anything up. Let's see. All right, that's good. We will wait for the relay click. Down in the meantime, there it is. Let's go check our right side first. We had, and they go up as the amp warms up, so now we're at -74. Let's check the negative end on the left. -74. Okay, so that is what we want. Then on the left we have 73.9. On the right we have, come on, 74 point, whatever. So our negatives are the same, but our positives are different. I'm going to say close enough, because at this point we're just swapping different components and seeing which ones are exactly the same. It's kind of like matching a transistor, and I don't have the equipment for that, for Zeners at least. This is not the repair I intended to make on this amplifier, but we had to because I totally messed up, and now we're kind of back where we want to be. We are back at where this thing was when it came here. Now, there is one other thing I noticed in this amplifier in my testing, and that requires me to turn on the tone generator. So, I'm going to set this to AC, and what we're going to look at is we're going to look at the speaker outputs. So the left channel might not work. We had some issues earlier, and yeah, we still have those same issues. So that comes down to a connector over here that is just not wanting to seat properly. So, but on the right channel, what do we have? Our 7.66 volts. So what's happening on the left channel is you can see in order to get to our gate board, we have to go through this connector with the gray wires coming out of it, and it's obscured by all these other wires. It's that one right there with the gray wires coming out of it. If I jiggle that connector, I get sound out of the left channel. So maybe I can demonstrate that actually with actual sound. Let's turn on again. Let's see if we have the same thing out of the left channel. We do. So that's interesting. Oh, did you see that? If I just do so much as move this thing. Look at that. I just twist the chassis. So what's up with that? Alright, so I've got you on the overhead. What happens when we jiggle these wires? Yeah, the other end of the connector doesn't seem to do anything. It's only that end of the connector. So there's that. You know what, folks? Maybe it's a bad trace on the board. Now that I am thinking about it more. Because if I push on the board... Okay, I found it. I was poking around more, and it's right here. I noticed things changed when I started touching this capacitor here. Underneath this shield is the first capacitor that the signal goes through. It is visible on the other side. You may recognize it from when we were looking over there earlier in the video. But yeah, those are just big old film capacitors, and that's where the signal passes through first. So I was like, is this solder joint bad? So then I started pulling on this wire. Let me unplug that real quick. And then, well, tell me if you can see what's wrong. Yeah, that happened. And it's a cold solder joint on the input capacitor. And it's kind of mind-blowing. Let's take a look underneath. I want to show you what's happening on the other side also, because we're going to have to reflow these. I will zoom in real close on the left channel's capacitor, the solder joint. It's right in here, and if the camera would be so kind, yes, yes. So that's the one we just yanked out. You can see there's nothing going through there, and then down here, this one's still in place, but you can see it's looking a little interesting, right? So let's go up to the right channel up here. And let's take a look at its solder joints. So that would be this one right here. You can kind of see, I was looking at it. Look at that. That's cold. Look at that ring around the component lead. That's bad. Let's look at the one up top. It's that one down low. Not as bad looking at the viewfinder here, but yeah, that's something we're going to want to reflow, resolder right now. We're going to do that on both channels, because if it can happen on one, it can happen on the other. Well, this is exciting. That was a good find. I'm impressed I was able to stay patient enough through all of this stuff, everything that's happened here. Now that we've got that figured out, let's plug this thing back in, and let's hope we don't have any more of that AC hum. And I hope that's been coming through on the video. Shame on me if it hasn't been, but here it is. It's gone. It is gone. We are dead quiet. Hey everyone, you haven't seen my face in a minute, so anyways, we were about to see that we have uneven input amplitudes, or output amplitudes, sorry. So let's get back to that. Let me show you what I was about to show you before I showed you that the left channel doesn't work. So anyways, turn our thing back on. That's good. But I'm gonna unplug that because we don't want to listen to that. That sucks. We'll turn our volume back up so we have a high amplitude. So let's go to AC volts and let's check what's happening at our input here. So at our input, we have 0.268 volts on the right and 0.268 volts on the left, which means if this amplifier is working properly, we should have equal numbers on each side of the amplifier, right? So let's check this number on the right channel. And that number is 7.65 volts AC. What's happening on the left? 8 volts AC. That's a huge difference. So what this means is we need to play a game called Follow the Signal, and we need to figure out when it is that this signal is getting out of whack. But wait, we may recall that we were making adjustments to that voltage across that one resistor that I shorted to ground back in the day. So maybe if we just turn this, we can get that voltage out of the output back equal to what is happening at the left. Let's go check the left. Yeah, so we don't need to play Follow the Signal. We probably would have found that it was happening right there if we played that game, but anyways, the relay clicked out. I wonder why that is. If we turn that back down, it'll come back. Yes. Okay, so that tells us right there something is still very wrong. Probably some fairly severe DC offset at the right speaker. So let's switch it to DC. Yeah. So that's bad. If we bring this up so the output is the same as the left channel, yeah, it's no wonder that the relay clicked out. So that's quite bad. We do not want 3 volts DC offset. So we need to make some adjustments to bring this thing back to reality here. So let's check our DC offset at the left channel, see if it's out of whack. No, the DC offset at the left is excellent. So we have a, yep, and if I take that and move it, it moves it way out of whack. So this is not your DC offset adjustment. We need something else. I think what we must do is we must go through the adjustment procedure outlined in the service manual, and that will let us get equal outputs out of each channel. So let's go back to that, shall we? I will go ahead and put the adjustment procedure on the screen for those of you who really want to follow along. So first thing we need to do actually is we need to set the distortion level or whatever with R131 and 231. That is going to be that adjustment pot right there. So we want no load, and we want 12 volts being output on the speakers. So the way we do that is we get a preamplifier. It says that these measurements must be made having minimum 5k ohm resistors in both terminals. So I'm going to assume they're talking speaker terminal. So I've got some 10K ohm resistors. I'm just going to put those in the speaker terminals for this adjustment. Okay, so we have the resistors in the speaker terminals like that. Kind of tough to see, but that's what's going on. At the left, 11.8, just call that 12. At the right, maybe that's it. Okay. So there's 11.8. Now, I'm gonna decline to measure across that resistor because I'm scared. Now we're going to adjust our 115, 215. So that would be the one in the middle here. So let's go to DC, and yeah, we already lost our thing there. We have to wait for our relay to come back. See if I can randomly turn the DC offset pot to get it to do what I need it to do. Okay, yes. Alright, I got it back. So our DC is wandering a little bit, but we can make it wander less, maybe, or worse. This adjustment is wild. Oh my goodness. What am I doing? I've never seen DC offset adjust quite like this. Are we stable now? Do we like it? Are we done wandering? Very interesting. No, maybe not. Okay, let's go back to AC. Where are we at with that? We've got our 11.78 on there, and then on the left, we've got our 11.78. How's our DC on the left? It too likes to wander some, it appears. Okay, so if the left is doing the same thing as the right, I don't feel so bad. Pretty interesting how they word step 2. It's like, why don't you just say, put a multimeter on there and adjust it so there's 0 DC. Maybe that's one reason why we're getting all this crazy wandering in the DC. Maybe they want you to attach those diodes in anti-parallel, which means you have one going one way and one going the other. So if you had DC going one way, one would turn on. If you had DC going the other way, the other would turn on, kind of thing. So I don't know, this seems to be perfectly fine to me as a way of adjusting. And then number 3, we want to do the distortion loaded. Okay, so 1, I don't have a distortion meter. 2, I don't have 4 ohm load resistors. I could take my 2 8 ohms and run them in parallel and do one channel at a time, but I still don't have a distortion meter. So I think I want to go back to the idle current like we talked about earlier. Let's turn this off because it's kind of weird getting those connectors on there. And yeah, I do think that they mislabeled the resistors on here. Like R505 and 605, they mean 305 and 405, and that's going to be these ceramic ones on your gate boards right here. Those are the ones you're going to want to measure across, because they don't exist on the power supply board, and it doesn't make any sense that it would be anything but these guys, you know. Let's see if these test points up here are what I think they should be. All right, we'll turn this back on. You can simply measure across these 2 test points here. So that makes my life quite easy, because I just looked at this oil view here, and yeah, you can see the resistor, it goes to the test points. So let's attach the other one here, and would you look at that? That is the adjustment, or the value we want. So the amp is warmed up, it's been on for a long time. It wants us to adjust for 30 millivolts across the resistor. I'd call that perfect, wouldn't you? Okay, let's take these off and let's go next door to the other channel. And next door we are a little high, so let's turn that down. The idle current adjustment, of course, is my probes are in the way. This is how we get into bad situations, right? Okay, wrong way. There. 30. All that good. And now it looks like it's time to adjust the peak clipping adjustment. So that to me means we got to get the scope out and we just need to see where we are clipping, and we can make an adjustment to try and get maximum power or minimum distortion kind of thing. Yeah, I'll get the scope set up. Okay, I've got everything hooked up. I have the two channels laid right across one another. We're using the Heath AP2510 because it's actually working properly, unlike that Carver C2. So, I've got some stuff going through. We see we've got 5.52 volts AC. We're going to turn this up until we see clipping. Let's see if anything explodes. Alright, so there's your clipping. We stop right there. So that's 36.4. Let's throw that into our calculator real quick. So that converts to about 165 watts per channel, which is well above the 150 that we're supposed to be getting out of this thing. So let's go ahead and look at channel 1, which I believe is the right channel. And if we pay attention, we should see the peak clipping light turn on, and I think I can barely see that. We clip pretty much evenly around 36.8. So let's go to the left channel, and it does about the same thing. Given the fact that, again, I don't have a distortion meter, I see this thing is performing just fine. Yep, we're getting warm, of course, and I'll bet you these resistors are quite warm to the touch, and they are. So, you know, this thing is working. I just realized I was being really stupid. I never switched the multimeter lead to see if we do get actual clipping at a different voltage. So let's do that real quick. Yeah, they're both doing it around 36.8-ish. Yeah, there's nothing wrong here. This amplifier is just fine. But this is kind of my general philosophy with a lot of this stuff. You know, should I have a distortion meter for this? Yeah, I should, because that's what the service manual says to do. But at the end of the day, the only thing that truly actually matters is how it sounds. Let's take a look at that. Let's see how everyone's favorite song sounds on this amplifier. And there it is. It is clear out of both channels. You love to see it. I'm gonna wrap this up right here, folks. This has been quite a journey, gotta say. Many lessons learned. Number one, recognize that a circuit board with a bunch of copper up top, that might be a ground plane, and you can jam your probe underneath that and short whatever it is you're trying to measure to ground. So that's not good. You don't want to do that. Number two, if you do get sparks and you do get smoke, stop. Just stop and get a full reset, and don't let that bother you. I let that bother me quite a bit multiple times in this video. It led to me making bad decisions. The right channel's regulated power supply might not have gotten so broken if I had not been foolish and just randomly tried measuring things. And it's still unclear to me whether me sticking my probe in there at that one point on the power supply shorted something and made that transistor explode, or if that was just about to happen due to the failure that had just taken place. I'm not sure, but regardless, should have gone slower, should have had a better understanding of how the amplifier works. And then number three, ask your customer, again, if you forgot what they said, what's wrong with it. I would have taken a far different approach if I had remembered that the only thing wrong with it was just the power switch broke during their use, actually. They didn't find it that way. And the left channel issue, which I'm really glad we found that. That was a really odd find. I don't think I've seen a solder joint go cold like that on a capacitor of all things. Capacitors generally do not get hot, especially at the input stage. Normally you see cold solder joints on components that get hot, like a power transistor, and the heat cycling will cause that. So whatever happened there, we did not have good solder joints. And then I guess fourth thing, understand your limitations if you don't have the right test equipment, and I tried to do that the best I could with just making good guesses about, we can get the idle current, that's easy. We can get the DC offset, that's easy. And then we know we really messed up this channel, but we never touched this one. And if this one's working, we might as well just match whatever it is that this one's doing, because we want equal things happening in each channel. So that's the approach we took with this one. We just made the right match the left, and now we have the same thing coming out of each one. We put it on our oscilloscope. We saw that clipping or distortion did not happen until we went beyond the rated power for this amplifier. So that to me says we're pretty healthy. We have 0 volts DC offset. We have healthy bias. We can set everything right, and it sounds good. So I think that's where we should stop here. Thank you so much for watching. I hope you enjoyed this video, and I hope you learned from some of these mistakes you saw me make. And like I alluded to earlier, if I didn't leave it in the edit, we've got something fun coming up here. This thing's partially hiding. I don't really have much place to put it because it's so big and I don't have a shelf that's strong enough to hold it. But yeah, this should be good. I've never worked on a... Okay, I have worked on a Marantz quad, but it's been a very, very, very long time. And the last time I worked on a Marantz quad, it went very poorly. But that was way before YouTube. So anyways, thank you everybody so much for watching. I will see you in the next one. And I can't guarantee it's going to be this. I don't know what's going to be next.